Hello everyone, in this video I'm going to go over solving absolute value functions. I'd like to start off by pointing out that the absolute value basically means the distance away something is from 0, meaning the number 5 is 5 spots away from 0. The number -5 is also 5 spots away from 0. If you think about it like actual distance, like whether you walk 5 feet forwards or walk 5 feet backwards, you still traveled 5 feet. The direction didn't make one positive and one negative. So, maybe thinking about absolute value like that helps you understand it better. So the tricky part is when you're solving absolute value functions, and since you can have positive and negative numbers plugging into them, and then you basically are outputting positive numbers, you need to solve for your both your positive and negative outcomes. So in this example right here, I have the absolute value of x plus 2 equals 4. So, 2 plus 2 equals 4, and the absolute value of 4 is still just 4. But you can take the absolute value of -4, and it'll still equal 4. All you got to do is set it equal to -4 to figure out what you should plug in. That could make the inside of that absolute value go to -4. And so that would be -6. -6 plus 2 is -4. Absolute value of -4 would also equal 4. So that's the tricky part with absolute values, to solve for both your positive and negative outcomes. Looking at the graph, I'm graphing the line. You're going to graph the left side of the problem, absolute value of x plus 2. That's what I mean by the left side. And then in a separate line, you're going to graph 4, okay? So the line y equals 4 intersects the graph absolute value x plus 2 times. It intersects at -6 and 2. That's what we just solved for algebraically right there. All right, so most of the time you're going to have two solutions. Sometimes you have no solution with absolute value problems, and that's because you're always outputting positive values. So notice how your graph is going upwards. So if I set it equal to something negative, like -4, for example, it's never even going to intersect. That's because you can plug in positive or negative numbers, but you cannot output positive or negative numbers. You can only output positive numbers, okay? So in times like that, just say the answer is no solution. So let's do a few examples. Here I have negative, and then I have absolute value of -4. So basically, just take the absolute value of -4, that's 4. This negative is on the outside of it, so it's not affected by the absolute value. So the answer is -4. You might be confused because normally you're thinking two negatives make a positive, don't they? And that's true, but that's not the same thing. I didn't write this down. I didn't write down negative and then -4 in parentheses. It was an absolute value. So when you take the absolute value of -4, it just turned to 4, and since that negative was on the outside, it still stayed -4. It's just me trying to play tricks on you, I guess. I don't know. So doing this, -4 plus 3, absolute value of -4 is 4 again. Absolute value of 3 is still 3, so the answer is just 7. Looking at this next one, absolute value of -2 is 2. Absolute value of 6 is still 6, so 2 minus 6 is going to be -4. All right, moving along. 2 times 9, and they're both in the absolute value. So this is 2. That's going to be 9. So the answer is 18. Now let's do some solving. So I have a variable here. So I have the letter A. So whenever you're solving, set one side equal to positive and one side equal to negative. And in this case, since there was no arithmetic to do, the answer is done. The answer is 5 and -5. Think about it. You can plug in a 5, or you can plug in a -5. Either way, the absolute value is going to output a positive 5. So here you have absolute value of B equals -2. So this one is going to be no solution because it's equaling a negative number. So if you don't understand why, think about it like this. Absolute value of 2 is 2, and the absolute value of -2 is still 2. So you're never going to equal negative 2. There's nothing you can plug in to get it to equal negative 2. All right. So here you have c plus 3 equals 12. So think about what you can plug in that'll equal it to 12, and then what can you plug in that'll equal it to negative 12, okay? So I know if I minus 3 to the other side, I'll get my two answers. So c is going to equal 9, or c can also equal negative 15. So if I plug in 9, I'll get positive 12. The absolute value of positive 12 is 12. And if I plug in negative 15, I'll get negative 12. And absolute value of negative 12 is 12. So here I have d minus 5 plus 2 equals 22. So the d minus 5 is in the absolute value. If there's something on the outside of the absolute value, see if you can get that to the other side before starting to solve. So this plus 2 is going to minus 2. And then I'll have d minus 5 equals 20. Now is the time to make your two equations. So d minus 5 equals 20, and d minus 5 equals negative 20. Okay, so I can solve this the same way on each of those by plussing 5 to the other side, and I get d equals 25. And then when I plus 5 on this one, I'm going to get d equals negative 15. So right now I'd just like to point out why it's important to get rid of the stuff that's outside of the absolute value bars before you split it up and make your two equations. So up here, if I just, normally when you solve this, you just drop the absolute value bars and you just continue as normal. So d minus 5 plus 2 equals 22. So we can combine minus 5 and plus 2 to make minus 3. d minus 3 equals 22. And so I'll add 3 to the other side, and I'll get d equals 25. Well, so far so good. But when you do your negative solution, d minus 5 plus 2 equals negative 22. You'll get d minus 3 equals negative 22. And then when you add 3 to the other side, you see you get d equals negative 19, which is the wrong answer. So if you don't clean up the stuff on the outside of the absolute value bars before you split it up into your two equations, it'll lead you into the wrong answer.